Hi everyone, and welcome to another video of this channel. So today we are going to prove that the area of a circle is equal to pi times its radius squared, and we are going to do this without a single integral. Now, a brief disclaimer before we get started: you will need to know limits before continuing. So in order to find the area of the circle, we will first inscribe a regular n-gon inside of it. So a regular polygon, it has n sides. And it never hurts to give a name to things. So let's just label the circle as circle O. The radius will be r. And the polygon itself will be p sub n, where n is the number of its sides. So now notice what happens when n gets really, really big. So as n is 100, 1,000, a million, this p of n closer and closer approaches O. And how do we represent that? Well, we represent this like this. So in math terminology, we say that the area of O, that's what these square brackets denote, is equal to the limit as n approaches infinity of the area of p of n, which is basically saying, once again, as n gets really large, the area of this polygon approaches O. So, in fact, what we're going to do is we're going to find the area of this polygon in terms of n, and then we're going to evaluate this limit to find O. So now what we're going to do is we're going to draw this triangle right here. And this triangle will be defined by one of the sides of the n-gon and two radii drawn from the center of the circle to the vertices on that side. So this would be A, this would be B, and basically note that this right here, so let's call this triangle Q, this is exactly 1/n of the total area of P, because there are exactly n of these triangles, so n times the area of one of these triangles makes up P of n. So we can say that the area of P of n is n times the area of Q. So now, in order to evaluate the area of Q, we are going to use the famous sine area formula for a triangle. So we still have our n here. And now the area of any triangle is two of its adjacent sides times the sine of the angle in between them times a half. So in this case, our two adjacent sides are r and r, right? OB and OA. The angle in between them, alpha. We can take the sine of alpha and multiply it by r squared over 2. Now, since r squared over 2 does not have anything to do with this limit right here, with n, we can pull this r squared over 2 outside of the limit. Now, we can do some sort of Scythe calculations. So right now, we are going to try to see what is the value of the sine of alpha as n gets really large. So first, we are going to drop the altitude from A to OB. And the sine of alpha is h over this radius. Now, let's notice this fact right here. So as n gets really large, h approaches this arc length AB right here. Now, why is this so? Well, as n gets really large, this segment AB right here, this closer and closer approximates this arc length. And this value h right here, this side length h, it in turn, so like the foot of this altitude gets pushed closer and closer to B. So h approaches AB, which in turn approaches the arc length. So actually, in the limiting case, as n gets really large, we can write that this side right here, is equal to this arc length over the radius. But what is this radius equal to in terms of n? Well, the circumference, the total circumference, that's 2 pi r. And then this arc length right here, that's exactly an nth of that circumference. So we can say that the length of this arc length is 2 pi r times 1 over n. So this right here, the sine of alpha, is in the end equal to 2 pi over n. So now we can rewrite this limit right here as n times 2 pi over n, because this 2 pi over n came from the sine of alpha. Now these n's cancel. We can pull this 2 pi out of the limits. This is just a constant. And we have that the area of this circle O is equal to r squared over 2 times 2 pi, which is equal to pi r squared. So I hope you like this video. I personally really like this method because, I mean, it is really pretty and it doesn't have a single integral. Now, for the challenge for you, is there any other way we could have found the area of this polygon with dividing it into triangular sectors, or maybe just without dividing it into triangular sectors that would have gotten us the same answer? So post about that in the comments, and thanks for watching. I'll see you in the next one.